Question 10, Part C. A and B are 2 points 200 meters apart. For what values of L is it possible to find a circular arc AB of length L meters? Justify your answer. You may use the results from parts A and B. Referring to Part B, Part 1, and in particular the diagram, the points P and Q on the circle are replaced with the letters A and B, and they are 200 meters apart. The arc length is L meters rather than 300 meters, and the angle at the center is still 2 alpha. So using the arc length formula, we can form this equation. Arc length L is equal to 2 times alpha times r. Rearranging this equation to make r the subject, we get r is equal to L over 2 alpha, and we'll call this equation number 1. Now again, referring back to Part B, Part 1, and in particular the isosceles triangle that's inside the circle, so that's this triangle here, which is redrawn here, sine alpha is equal to 100 over r. And I've written this equation here. Rearranging that equation to make r the subject, we get r is equal to 100 over sine alpha. We'll call this equation number 2. Now, equating equations 1 and 2 via r, we have 100 over sine alpha is equal to L over 2 alpha. Taking the reciprocal of both sides of the equation, we get sine alpha over 100 is equal to 2 alpha over L. Multiplying both sides of the equation by 100 to isolate sine alpha, we get sine alpha is equal to 200 alpha over L, which can be written as 200 over L in brackets times alpha. So 200 over L becomes the coefficient of alpha. And we'll call this equation number 3. Sine alpha equals 200 over L in brackets times alpha. Now equation 3 has a solution if the coefficient of alpha, that's 200 over L, is greater than 0 and less than 1. So referring back to Part A, Part 3, the equation sine x equals mx has a solution if m is greater than 0 and less than 1. So this is the solution from Part A, Part 3. And we found that sine x equals mx has a solution if m is greater than 0 and m is less than 1. And in this case, m is represented by 200 over L. So we can form this inequality. 200 over L is greater than 0 and less than 1. Multiplying all terms by L, we get 200 is greater than 0 and less than L, which implies that L is greater than 200. Therefore, a circular arc AB of length L meters is possible for values of L greater than 200.